Alright, in this video we will continue talking about finite geometric series and finding the sum. The only thing that's new here is that now we're going to find the sums when the series are given in what's called sigma notation. And we did talk about this with arithmetic series, but just to refresh on that. This symbol that I just drew, that's the sigma symbol. It's a Greek letter, and in this case it basically means sum. And the way to read this is that it's the sum of a series starting at some value down here, and you can use any letter you want. N, M, K is another letter they commonly use. I'll just use N right here. Starting at whatever this is. So this number right here means plug in N equals 3 to get your first number. Okay. So let's do a real simple series. Let's say we had 2n. So plug in n equals 3 to get your first value. So if I plugged in n equals 3 right here, that means my first value would be 6. Okay, then the next thing I would do is plug in n equals 4, because that's the number that comes after 3, and then I would get 8, and then I'd keep going until I get to this number. Okay, and that's the last number that I plug in to get my last value. So 6 plus 8 plus, you keep that pattern going, and the last thing would be to plug in 10 right there. That turns out to be 20. This is now our series. Sigma notation, the purpose of it is just to give us a faster way of writing out a series. So with that said, let's actually use that notation to solve these two problems, or to find the answers, I should say, find the sums. And it doesn't matter which formula we use, we'll just get a little bit of practice using both. So let's start out by expanding out this series. And I'll show you kind of a shortcut for this later, but for now, just to get the practice, let's do this. So here's what this says. This says to find a sub 1, to find our first term, we have to plug this number in, m equals 1. Okay, then we're going to add to it our second term, and we're going to get that by doing m equals 2. Then we're going to add to it our third term. We'll get that by doing m equals 3. And then we keep going until we get to this number. Okay, when we plug in m equals 7, that's going to be our seventh term. Why 7 terms? Because there are 7 numbers from 1 to 7. Alright, so let's get our first term. So 4 times negative 4, and now I'm plugging in m equals 1 right here. So m minus 1 would be 1 minus 1, and that's 0. Anything to the 0 equals 1, and 4 times 1 is 4. So there's our first term. Okay, second term is we're going to plug in now m equals 2, so negative 4. I'm going to plug in 2 right here now, so 2 minus 1 is 1. Negative 4 to the 1 is negative 4, and 4 times negative 4 is negative 16. Okay, and like I said, we'll see a kind of a shortcut for this, a pattern in just a sec, but for now I just want to show you how to expand it the long way. Now we're going to plug in m equals 3 right here, so 3 minus 1 is 2. Negative 4 to the 2 is 16. 16 times that 4 is 64. Okay, we don't need to do every single one. We can just come out to the last one, and now we're going to plug in 7 right here. So I have a plus and then a whole bunch of terms in between, and then we'll get the last term. Again, if we plug in 7 for m, 7 minus 1 is 6. Negative 4 to the 6th is a big number. That's 4,096. And then times that 4 would be 16,384. So this right here, this is actually our series. Now we can use either this formula or this formula. It doesn't matter which. Let's just use the one on the left, so this one right here. Okay. So how does that work? Well, we need to know the first term, and we know it. The first term is 4. So we're going to use, let me just move this formula down a little bit so we can have some more space to work with here. Okay, so we are going to use this one right here. Okay, and we're finding the sum of 7 terms because there's 7 terms right here. So S of 7 equals a sub 1, and that is this number, that's 4, minus a sub n means the last term, and we found out that the last term is 16,384. Times r. Now the question is, how can you find r? Well, I told you there'd be a shortcut. If you look at this, what times 4 is negative 16? That would be times negative 4. Negative 16 times negative 4 is also 64. So the key is to notice this number. This number, that number right there, is r. It's the number that's being raised to the power. That's going to be your common ratio. So if you look at problem number 2, ask yourself what would be the r right there, and the answer is negative 3. R would be negative 3. Okay, so that's the shortcut so that you don't have to actually write out that whole series like we just did. I just want to show you the longer way first. Sometimes you appreciate the shortcuts if you know the long way first. Okay, and then the bottom of that fraction for the sum is 1 minus r, so that would be 1 minus negative 4, which is like 1 plus 4. And now we can just simplify this. Negative 4 times this thing is 65,536. And then the bottom 1 plus 4 is 5. When you simplify this out, this becomes 65,540. Divide that by 5 to get 13,108. And sometimes people are wary about that. They say, well, am I supposed to get such large answers? Yeah, in many cases you will, because these are pretty large numbers that we're dealing with whenever we're dealing with exponents. All right, so if you haven't tried yet, pause the video and see if you can do this problem. We're going to use the second formula this time. Okay, now that we know the shortcut, we can just directly plug it in. So we want S of 8 because I'm going from 1 to 8. So I know there's going to be 8 terms. And then this tells us put the first term in here. Well, all we need to do really is get the first term. So let's do that right now. So A sub 1, we'll plug in n equals 1 to this formula. So we'll have negative 4 times negative 3 to the, and now I'm plugging in 1 right here. So 1 minus 1. That's the same as negative 4 times negative 3 to the 0. Anything to the 0 is 1. Negative 4 times 1 is negative 4. So that is what our first term, our A sub 1 is. Okay, now we have this rest of the formula to fill in. So 1 minus r. And remember, r is that number. R is negative 3. So 1 minus r is like 1 minus negative 3, which is 1 plus 3. And then up here, the only thing to be cautious about is the order of operations. So I'm plugging in r here, and then n is my number of terms, which we said was how many terms there are from 1 to 8, and that's 8. Okay, the reason I said to be cautious is because a lot of people will do this. They'll say, well, minus negative 3 is like 1 plus 3, and so I have to go 3 to the 8th. And that's not always going to work. In this case, it will, because we're turning out to have a positive number. But you don't want to do 1 plus 3 and say, well, that's going to be 4 to the 8th. That's an order of operations error. You have to do the exponent first and then the subtraction second. So let's simplify this. So we have 1 plus 3 on the bottom is 4. Then we have 1 minus negative 3 to the 8th power is positive 6,561. This 4 and this 4 will cancel, so this is just negative 1 now. So we have negative 1 times 1 minus 6561 is negative 6560, times this negative 1 outside gives us positive 6560. And that is the sum of that geometric series.